Hi, we're going to look at understanding different parts of a quadratic graph or parabola. Um, Parabola tells us so much information, and we're going to break it down into little pieces. So let's start with an actual parabola. So you get a graph of a parabola whenever you have an equation that has an exponent of 2. Exponent of 2 is going to give you this kind of graph. Okay, so now of this graph, there's a few pieces in it that we need to know. Uh, Down the very center of a graph, I'm going to draw this little dashed line. Down the center, that green dashed line has a specific name. That name is called the axis of symmetry. Um, it splits our graph directly in half, and the left side and the right side, they, they're the exact same features, the exact same parts. If I were to fold the graph over on each other, both lines would line up with each other. Okay, so axis of symmetry, left and right are the same. Now we can write this as an equation. The equation of this green dashed line is going to be x equals, and in this case, we cut through we cut through 2 on the x-axis. So x equals 2 for that. Another important feature in this is called the vertex. The vertex is that coordinate right at the very, it's either going to be at the bottom or at the very top where that graph kind of makes its turn. That vertex we write as a coordinate, x comma y. So in this case, our vertex is going to go to the right 2, down 2. And again, that's always x, then y. And one last key feature on this parabola over here is called the y-intercept. Whenever you're dealing with lines, y equals mx plus b, b is that y-intercept. When we have a parabola, we still can get, and we still will have a y-intercept. In that case, it's going to be right there. We call that the y. I'm going to abbreviate that y-intercept, and we can write that as two ways. I can either leave it y-intercept equals 2, or I can write that as a coordinate. And in this case, our coordinate, we go left and right 0, and we go up 2. The y-intercept will always be 0 comma something, always that 0 in the beginning. So two ways of doing that. So y-intercept equals 2, or you could write 0 comma 2. Vertex is always a coordinate. Axis of symmetry, always an equation, x equals. Okay, now with the graph, you have other little descriptions. One of them is called either a maximum or a minimum, and we can find the max or min value. So a maximum is the graph has a maximum height. So think of a roller coaster where this one, you're going up, 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 and you hit the very top, and then all of a sudden, whoosh, you come flying down. That roller coaster has a maximum possible height. This graph has a maximum possible height. We can abbreviate and just say max. The height of that is just your y values. How high does it go? It goes 1, 2, 3. Now, why doesn't it go down? Well, let's also talk about what these arrows mean over here. So at the end of those graphs, it says that those lines continue moving. These lines are going to move in two different directions. They're going to go down, but this one is also going to inch its way very slowly to the right. This one's going to inch its way, it's going to go down very quickly and inch its way very slowly to the left. Same thing over here. We go up very quickly, but very slowly we push out to the right. We go up and we very slowly push out to the left. So here we have a maximum possible height. Down here, think of that roller coaster again. It's going around, up and down, whatever. And all of a sudden we dip down very, very low, and then whoosh, it flies up. That lowest part of that graph, is this is the minimum, this is the lowest that we will ever go. And we say it's a minimum. And that minimum, the lowest we go, think of an elevator. How much do you go up and down? Well, the highest we go is to the third floor up top. The lowest we go down here is -1. Does it go any higher? Well, think of these arrows. They're going to go up and they're going to continue to forever go up and they're never going to stop. So the elevator is just going to keep going, 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 going. We have no idea where it stops. It never stops. So maximum, minimum. You also have something called solutions. A solution is where your graph crosses the x-axis. So up top, we have two solutions. Two solutions. Our two solutions, where do we cross the x-axis? First, we cross at -1, and we cross at 1, 2, 3, -3. So we have two different solutions. One's x equals -1, x equals -3. Well, I guess I did that one not how I wanted to do it. Down here, you also have two solutions. We cross there. So two solutions. We're at x equals 0, and then x equals 1, 2, 3. Does this graph ever cross the x-axis? No. So if a graph doesn't cross the x-axis, we have no solutions. No solutions. I'm going to add one more in here. Sorry that it's sloppy. So this graph, we end up having only one solution. That one solution happens to be at 1. So you have three possibilities. Two solutions, where you hit the graph twice. You have one solution, where you hit the graph only once. Or you could have no solutions, where your graph never hits that x-axis. So graph hits the x-axis twice, hits the x-axis once, hits the x-axis never. The last thing that we can get is something called domain and range. Domain and range. So domain and range is another way of saying x's and y's. Domain is x's, range is y's. So talking about the x values, this graph, we say it opens up, and this line will continue to go up, but very slowly they inch their ways outward. So they're always going to go up and they're always going to go out forever. Okay, if I'm talking about x's, my domain here, since it will always go up and out, I don't care about up. All I care about is that it very slowly moves outward forever. So we can then just say it is every single number ever. This graph will forever go up and out. I'm going to hit every number going that way. It's going to go up and out this way. I'm going to hit every number in the right direction. Always moving out, out, out. We say the domain is all real numbers. Okay, now your range. Your range is your y values. Where does this graph hit your y, or what y values does our graph hit? Well, we start here at 0, and the graph only goes up. So we say that as y, because we're only talking about y's, and they're greater than, because we start at 0, y is 0, but everything's going to go above 0, so we're going to say it's greater than 0. But do we exactly hit 0? In this case, yes. So we put that equal sign under there. Domain, all real numbers, because we hit every number ever. Range, we start at 0. We're talking about y's. It hits 0, that's why the equal. Greater than says we go up. down here, domain. And I'm going to shorthand this. So since this graph is going down, we say it's opening downward. It's going to forever go down, but it's forever going to go really slowly to the right, really slowly to the left. So my domain, I hit every single number ever. So instead of having to write this all real numbers all over again, I draw a special little R. I call it the fancy R. Line, line, make your big R. I call this all real numbers. So it means the same thing. My range. Range, we're talking about Y's. So we're talking about Y's. Where do we start? Well, we're starting at 1, 2. We start at 2. Does our graph hit 2? Yes, it does. There's an equal. Now, do we go above 2 or below 2? Well, this is opening down and getting all those negative numbers, so we're going less than. We're going to say y is less than or equal to that 2. These are all the different parts of understanding a quadratic graph, parabolas.